You were looking up at the night sky, and now you are seeing glowing lights dancing, not at the planet's north or south pole, but somewhere in between. Sounds strange, right? But that's exactly what's happening on Neptune right now. Unlike Earth, where auroras shine at the poles, Neptunes appear in the middle of the planet. And that's not even the craziest part. Something even more shocking has happened. Neptune's upper atmosphere has become hundreds of degrees colder since the Voyager 2 spacecraft visited in 1989. That's a massive drop in temperature for a planet so far from the sun. For years, scientists couldn't spot Neptune's auroras, and now we know why. But before we dive into how scientists discovered Neptune's auroras, make sure to subscribe this channel because it's the best way to support us. And don't forget to share this video with your friends so they can learn something amazing too. On our Earth's sky, near the North and South Pole, colorful and beautiful lights are dancing. Every second, our massive sun constantly sending out tiny, invisible energy particles called solar wind. When this solar wind reaches Earth, it collides with our planet's magnetic field, which acts like a shield protecting us from harmful space radiation. At the North and South Poles, the Earth's magnetic field is weaker, which means it is the place where magnetic field coming out from the Earth core, and there is small gap like how the apple head looks like. From this gap, invisible solar particles can enter our atmosphere. Our atmosphere have oxygen and nitrogen in the air. When they enter in our atmosphere, solar particles hit gases of oxygen and nitrogen in the air. At this point, they create glowing light, just like a giant natural neon sign in the sky. Near the North and South Pole sky, we can see mostly covered with green color. For a long time, people didn't know what auroras were, and some thought they were spirits, dragons, or messages from the gods. Later in 1619, Italian scientist Galileo Galilei named them Aurora Borealis. After some centuries, in 1968 for the first time, humans saw auroras from the space. During the Apollo 8 mission, astronauts saw glowing lights over the Earth's poles as they orbited the planet. Then later on different missions, scientists have found auroras on Jupiter, Saturn, Uranus, and Neptune. But there's a problem with Neptune auroras. In 1989, Voyager 2 captured the Neptune from far distance, so it's not visible clearly. Then scientists declared Neptune might have auroras, but they did not confirm. On the research of auroras in the 20th century, scientists discovered the auroras are caused by the solar wind. Later, the most powerful space telescope ever built, James Webb Space Telescope, was launched on December 25, 2021. It captured the Neptune's auroras in 2023, and it was the first time we got a clear confirmation of auroras on Neptune. Scientists had suspected them for years, but only Webb's advanced infrared cameras could detect them properly. James Webb not only just take a clear image of Neptune, what it saw on the Neptune will blow your mind. On Neptune's atmosphere, for the first time ever, scientists found a strong signal of a special molecule called H3+, which actually forms in auroras. In Webb's images, Neptune's auroras appear as glowing cyan spots, showing exactly where they are happening. Neptune's auroras are different from what we see on Earth, Jupiter, and Saturn. On most planets, auroras appears at the poles, but on Neptune they glow in the middle regions. This unusual placement is due to Neptune's strange tilted magnetic field. To imagine this, think of auroras appearing over South America instead of the North or South Pole. Because Neptune's magnetic field is tilted 47 degrees from its rotation axis, so they show up in unusual places far from the planet's poles. This happens because auroras from where magnetic fields push energy into the atmosphere. This discovery is huge because it helps to understand how Neptune's magnetic field and how its atmosphere reacts to energy from sun. These solar particles travel all the way to the Neptune, shaping its atmosphere in ways we've never seen before. For the first time since Voyager 2 visit, scientists measured Neptune's upper atmosphere temperature using James Webb. The results revealed a surprising clue. This might be why Neptune's auroras stayed hidden for so long. Neptune's upper atmosphere has cooled by hundreds of degrees since 1989. In 2023, the temperature was just half of what Voyager 2 recorded back then. A much cooler atmosphere means much fainter auroras. This extreme cooling could be why Neptune's auroras stayed hidden for so long. Even though Neptune is 30 times farther from the sun than Earth, its atmosphere changes a lot. James Webb Telescope, uncovering mysteries in our solar system and exploring distant worlds around other stars. Webb is also helping scientists understand the universe's origins and our place in it. This groundbreaking mission is led by NASA with support from ESA and CSA. Thanks for watching till the end. If you're enjoying this journey through space, don't forget to support the channel, like and subscribe to stay updated on more amazing discoveries. Your support helps us bring more fascinating space stories to you.